Good morning children. Today let us continue with our class of haloalkanes and haloarenes. Yesterday we have seen how to give the names for haloalkanes. Today let us continue with the isomerism in haloalkanes. Do you remember the term isomerism? This also we have studied last year. Let us just pass through the definition once again. Isomerism means it is the phenomenon in which the compound possesses same molecular formula but they have different structural formula. The phenomenon in which compound possesses same molecular formula but have different structural formula, that is termed as isomerism, and the compounds are termed as isomers. So now we are going to study about the isomerism which is present in case of haloalkanes. Haloalkanes generally shows both the type of isomerism, that is structural isomerism and stereoisomerism. First let us pass through structural isomerism. As the term indicates, structural isomerism means it's the type of isomerism again in which the compound possesses same molecular formula but different structural formula. The type of isomerism in which compound possesses same molecular formula but different structural formula is termed as structural isomerism. In case of haloalkanes, they exhibit two types of structural isomerism, that is chain isomerism and position isomerism. Haloalkanes will be exhibiting two types of structural isomerism, that is chain isomerism and position isomerism. Let us study with the help of an example. You just consider the formation of chlorobutane whose molecular formula is C4H9Cl. Let us consider the structures. We can write it as, and the same compound can be represented in another structure. According to the IUPAC, the first compound is termed as 1-chlorobutane and the second compound is termed as 1-chloro-2-methyl-propane. Again you just see they possesses the same molecular formula but structurally they are different. Since they are showing difference in carbon skeleton, the first compound contains a straight chain of 4 carbon atom, but in second you can see a straight chain of 3 carbon atom. So this type of structural isomerism in which the compound possesses same molecular formula but shows difference in the carbon skeleton, a carbon chain, is termed as chain isomerism. Is it clear children? Chain isomerism is a type of structural isomerism in which compound possesses same molecular formula but shows difference in carbon skeleton, in carbon chain. So this type of structural isomerism is termed as chain isomerism. Now let us explain position isomerism with the same example. This is again 1-chlorobutane. The same compound we can represent it as 2-chlorobutane. So again both of them possesses the same molecular formula C4H9Cl. They have the same molecular formula C4H9Cl. So here you can see that only the position of substituent is different. In the first compound, the substituent chlorine is in first position, but in second compound it is in second position. So this type of structural isomerism in which the compound shows difference in the position of substituent or functional group is termed as position isomerism. So these are the two types of isomerism, structural isomerism exhibited by haloalkanes. Okay. Now let us pass through stereoisomerism. Like structural isomerism, you have studied that the second type of isomerism is stereoisomerism. In stereoisomerism, again they will be showing the compounds will possess the same molecular formula but they shows difference in spatial arrangement. The type of isomerism in which compound shows difference in spatial arrangement is termed as stereoisomerism. This also we divide it into two types, that is geometrical isomerism and optical isomerism. Children, you may be remembering that last year we have studied about geometrical isomerism in detail, but we didn't mention anything about optical isomerism. Now in this particular chapter, haloalkanes exhibit the type of stereoisomerism which is termed as optical isomerism. So let us study about optical isomerism in detail. Before studying about optical isomerism, we have to pass through certain terms. First one in that is plane polarized light. Have you heard about plane polarized light? Or we generally discuss PPL. Plane polarized light or PPL. Do you know white light consists? White light means the normal light. It consists of 7 colors. That means they possesses different wavelength. When we pass this white light through a Nicol prism. Nicol prism means it is just a prism, transparent prism which is made of calcium carbonate. When you pass this ordinary light through Nicol prism, the resultant light will be possessing only one particular wavelength. That means it will be able to vibrate only in one direction. For example, you consider this, if you consider it as the ordinary light which vibrates in different direction. This is the ordinary light which vibrates in different direction when it is passed through a Nicol prism. That is, as I told you, the prism which is made of calcium carbonate, transparent calcium carbonate, the resultant light which comes out that vibrates only in one particular direction, and that is termed as plane polarized light or PPL. Is it clear? When we pass ordinary light, that is the light which vibrates in different direction through Nicol prism, the prism which is made of transparent calcium carbonate, the resultant light is able to pass to vibrate only in one direction, and it is termed as plane polarized light. Here the role of Nicol prism, it acts as a polarizer. Is it clear, children? So this light, this plane polarized light is able to rotate, or it will be rotated by certain substances into different directions. The substances which can rotate PPL towards left is termed as levorotatory, and if it will be rotated towards right, then it is termed as dextrorotatory. And this particular property of the substance which can rotate this plane polarized light either towards right or towards left is termed as optical activity, or it is termed as optical isomerism. Is it clear? So the substances, the samples which are able to rotate plane polarized light either towards right or towards left is termed as optical activity. This particular property is termed as optical activity, or it is termed as optical isomerism. Let us explain it with the help of a simple diagram. If you just consider, that is, now the instrument which is used to explain this plane polarized light, the instrument which is used to explain optical activity is termed as polarimeter. Have you seen this year's paper, children? This question was asked for 1 mark. What is named the instrument which is used to learn this optical activity? That is called polarimeter. Actually, polarimeter consists of 2 Nicol prisms and a glass tube. That is, first this light will be passed through a Nicol prism which is termed as polarizer. This is termed as polarizer, and the resultant light will be allowed to pass through a glass tube which contains the sample of solution. This contains the sample of, this is a glass tube which contains the sample of solution, and the light which comes out will be analyzed by another Nicol prism. This is also a Nicol prism which is termed as analyzer, and it is used to study the angle through which the light will be rotated. So the polarimeter consists of 2 Nicol prisms and a glass tube. The first Nicol prism is termed as polarizer, which will be passing, that is, which will be allowing the plane polarized light to pass through the sample which is present in a glass tube, and the resultant light will be passed through this analyzer, which is used to measure the angle through which the light will be rotated. This is how we can find out the angle through which the light will be rotated, and this particular activity of the samples which is able to rotate plane polarized light is termed as optical activity or optical isomerism. Is it clear? Let us study in detail in next class.